Hello, my name is Ken Rehbehn. I'm an industry analyst tracking the evolution of communications technology serving the emergency services. Today we're going to reflect on how LTE, 5G are evolving to support public safety deployments. We'll begin by examining the transition of our critical communications networks from the narrowband to the broadband. We'll examine what's happening in North America with FirstNet, as well as some advances that are occurring in Canada. I will talk about some of the considerations that are important for the regulators in the region to consider during this transformation. And finally, we'll look at the impact on the emergency services going forward. For decades, group voice has been the fundamental foundation for emergency services communication, for command and control. Replacing group voice, or frequently called push-to-talk, with data is an important step forward and does help boost the efficiency of our emergency services operations. But it's important to remember that group voice and push-to-talk must always be an option available to the emergency services. This is important for the case of the data network failing. It's important as well to handle aspects, use cases, that data networks were not designed to accommodate. Voice is a very flexible and resilient path for communications. And group voice means the entire group hears a message when an incident commander sends a message. It's important that a nation always provide a basic group voice capability to its emergency services during operations. Of course, LTE 5G yields important benefits to the emergency services. Clearly, voice communications with push-to-talk has drawbacks. First, it's a very limited channel. Only one person may be speaking at a time. The amount of information that can be transmitted with voice is very low compared to the transmission of a picture or a video that, when viewed, yields so much more information, so much faster. For this, LTE 5G communications is an important supplement to voice. Some examples of how we use data with the emergency services include getting basic map information that's up to date and perhaps overlaid with information about the actual incident that's underway. We can now provide with data information about details of the scene that a responder is going to. What type of structure? What's happened there before? Are there any hazardous materials stored in that environment? We can provide information about all of the members responding. What are the details of the unit? What type of unit? Who is staffing the unit? What capabilities does that unit have? Another enormous benefit is by providing effective data capabilities. We offload transmissions from the voice channels and leave the voice channels clear for only the most essential messages. The benefits on operational efficiency when data is introduced is enormous. An additional aspect that data brings is the opportunity to improve the command and control systems that are available to the emergency services. The ability to track the status of members operating at an incident, to have status information, not just where people are, but what is the quality of the air supply? Are people running out of air if they are a firefighter deep in the structure? The status of emergencies, the orange buttons on our radios or devices, when you push it, the ability to see that this has happened. These sophisticated mechanisms fold into potential common operating picture capabilities that will be invaluable for incident commanders managing complex operations. Drones are beginning to have a big impact in responses. Drone as a first responder is a capability where a drone is sent flying before law enforcement resources arrive at an incident. The drone has the ability to relay back video showing what is going on at the incident so that responders that are arriving are better prepared to deal with the incident and perhaps de-escalate a problem before it gets worse. Body-worn cameras offer another valuable picture into what reality is for incident commanders and control rooms that are not at the scene. This is enabled by the LTE 5G broadband capabilities. For an incident commander that's at the scene, a video feed from closed circuit TV can provide additional information about the situation, the crowds, the status that is valuable, all enabled by broadband over LTE and 5G. Many nations look at the transformation from narrowband to broadband as an opportunity to achieve cost savings by retiring the narrowband voice systems. European regulators are pursuing this, a goal to reduce operational expenses and eliminate the Tetra system. I fear this may be a mistake. Group voice communications, push-to-talk over narrowband networks, provides a second communications path if the LTE 5G network is not available. Now, there are features in 4G, 5G that should allow for communications to continue when there's no network. We call that a direct mode capability, the ability of two radios to communicate even when there is no network. In LTE, the quest to provide direct mode failed. No modem supplier incorporated direct mode into the modems. This is changing with 5G. Because of the possibility of vehicle-to-vehicle, vehicle-to-roadway, sometimes called V2X capabilities, we have direct mode capability with a feature called side link entering into the modems. We expect this to become common and potentially useful for the emergency services. I fear, however, this is still inadequate. My fear is that the power transmission levels of 5G are too low. A firefighter who is several floors away from another firefighter that they must communicate with may not be able to have the signal penetrate through the concrete the way a more powerful Tetra or tetrapole device would transmit. Another important factor is the failure of a mobile network operator's network. This is not as unusual as you would think. We've had large networks fail, either because of disaster after a hurricane, or perhaps because this area was not economical to cover with a tower, or there was a mistake and accidentally the network has failed. Retaining an independent narrowband network as a backup is ideal, and regulators should remember the value of the narrowband network and not be in a rush to give back the spectrum for the narrowband network. The situation in North America is very different from the rest of the world, and it's worth spending some time on. The US spectrum had been set aside back in the 2000s, 1990s, with a block of spectrum called the D block in 700 that was destined for public safety operations. When placed on the auction block with the provision that a mobile network operator buying that spectrum would have to make quality of service available to the emergency services, no mobile network operator bid, and the spectrum was unused. The FCC attempted to just reassign the spectrum back into the general auction pool, but the emergency services organizations of the United States fought and demanded that the spectrum remain in the hands of the emergency services. A compromise was struck. A new agency called the FirstNet Authority came into existence with ownership of the spectrum and a mandate from Congress that the spectrum be deployed in a public network for maximum efficiency and use of the spectrum, but with those requirements for quality of service, priority, and preemption that would give the emergency services top-level use of the spectrum. AT&T is the operator behind that spectrum now today and is using it to their competitive advantage to bring in new customers, taking customers away from their competition. The incumbent competitor in the United States market was Verizon, with probably 80% market share in the emergency services. Even with FirstNet being created, Verizon continues to keep market share as much as possible. They have matched the capabilities of FirstNet and aggressively compete head-to-head against FirstNet. Even T-Mobile, the third player and a much more recent addition to the United States cell phone service provider market, has crafted service plans with priority and aimed that at the emergency services. One of the capabilities that AT&T was to provide with FirstNet was 3GPP standardized mission-critical push-to-talk. And they have done so. There is a server that they operate with that capability. Unfortunately, AT&T, in order to recruit as many subscribers as possible, has also deployed the Motorola 3GPP solution. Unfortunately, the Motorola 3GPP solution is restricted to Motorola devices, not truly interoperable, creating a tremendous problem in the United States that prevents the 3GPP mission-critical push-to-talk from achieving the goals of nationwide interoperability. It's worth noting that AT&T as well has offered over-the-top push-to-talk services that also compete with the 3GPP offering and the Motorola offering. The result, after many years of AT&T deploying, is actually more confusion than what we had before FirstNet. In Canada, the situation is different. The federal government in Canada is not moving. They are in a study mode. Recent papers, however, have embraced a concept that has appeared in Ontario, where police agencies, frustrated by the lack of progress to get a government QPP network in place, began to deploy using band 14 spectrum with a trial license. This project is called the Public Safety Broadband Network Innovation Alliance, or PIA, and it is being welcomed in other parts of Canada. I suspect we will see the hybrid private network based on band 14 combined with public networks with roaming to be the basis of what happens in the rest of Canada. And potentially a very good model as well for South American nations. So what should regulators think about? There are several issues. Please bear in mind, moving to a QPP network is an expensive commitment for a mobile network operator. It has implications for their support of the best effort consumer customers. It has cost impacts just to harden cell sites and achieve the backup power that is required for a robust emergency services network. The characteristics of emergency services networks are not the same as the characteristics of a mobile network operator serving consumers. Another dimension that becomes an issue is multicast. Mobile network operators do not provide broadcast. Instead, they're unicast traffic flows. A large community of push-to-talk users, however, benefit from simultaneous transmission using eMBMS capabilities in LTE, so that one message is replicated automatically and sent to all listeners without duplication. Much more efficient and better quality for the emergency services users. But to support broadcast, it requires some cell site resources on the air interface that take away some capacity for the mobile network operator. It's important for the regulator to understand that supporting the emergency services comes with a cost for the MNO. This is a difficult challenge. Network failures as well can be brand damaging for the mobile network operator. They're very visible when the emergency services cannot function. Another factor to consider is net neutrality. This has been an issue in Europe and potentially an issue in South America. If a legal structure in a nation prohibits treating IP traffic differently, depending on who the user is, you may have a problem with net neutrality. In Europe, there were changes to legislation country by country to make it possible for the emergency services to be treated with better priority than other users. Resilience is an issue. Regulators need to consider that MNO networks do fail. We've had major failures this year with AT&T, last year with Rogers in Canada, as well as Optus in Australia, and the year before that with Rogers again. Understand that a single mobile network operator supporting all of your emergency services may create a risk for your nation. There are approaches to get around this. The MOCN network architecture is one way, although it is expensive and challenging to implement. Flexible roaming that can quickly take over when the mobile network operator has failed and move the traffic for emergency services to another network that is working may be a more effective option. It's important for regulators to study the roaming implications for emergency services. The nation of France, with their ACMOS project that will provide 4G services for the police, fire, and rescue is putting a lot of study and effort into using roaming effectively as a resilience mechanism with multiple networks backing up. Finally, let's talk about the impact for the emergency services. It's worth knowing that in many major jurisdictions, the emergency services use data services today. It may be in the form of a tablet that is in the hands of a team leader or a police officer. It may be a smartphone application that's in hand, but many cities across the world have already started using data services. Now, these data services are not coming with protection with quality of service, priority, and preemption, but they still provide a big benefit. And the narrowband network remains available for the most urgent of message and for overall coordination. We also have some quality of service, priority, and preemption offerings in South America. One that's notable is in Mexico, operated by Airbus as a secure MVNO to support public safety in Mexico. In Argentina, we are in early stages of 3GPP mission-critical push-to-talk being deployed by Leonardo in conjunction with a mobile network operator in Argentina that is prepared to offer quality of service, priority, and preemption. One factor for the emergency services, though, is of handsets. The smartphone is a very, very poor substitute for a hardened device that is designed for emergency services use, for the law enforcement officer on the beat or a firefighter going into a structure. The demands, the requirements for these devices call for better batteries, louder speakers, large knobs that can be manipulated with gloves. A simple smartphone with a glass screen is inadequate. And today, there just aren't very many devices on the market that are as perfected as the narrowband terminals that we've had. We do see some interesting hybrid devices, and hybrid's important because it allows support for that direct mode capability with the lower frequency and higher power technologies of Tetra or DMR or even analog when a network is not available. A hybrid device will also support LTE, hopefully with the 3GPP mission critical push to talk. Some of the early hybrid devices that are on the market today supporting both 3GPP mission critical push to talk and legacy land mobile radio include the L3 Harris X200 series with P25 and the just announced Sapura SCL3, which combines Tetra and LTE. It's worth noting that the largest suppliers, Motorola Solutions and Airbus, are not coming out with standards-based devices that are hybrid, supporting the mission-critical push-to-talk and the legacy standard technologies. There is an effort by these companies to move slowly in order to protect market share of the legacy narrowband networks that have been deployed. For emergency services, resilience is vital. It's central to the discussion. Ultimately, all emergency services operations can revert to voice only. Terse communications that effectively control a group will always work. To make this possible, it is essential that direct mode be available as the ultimate backup when a network goes away or the teams go into areas without a network. In the event of large-scale failure, the emergency services organizations will look for roaming between MNOs in order to stay operational. Regulators face a difficult challenge as you consider the needs of your emergency services organizations, your competitive picture in your nation. Regulators must be careful to be smart about the spectrum. Do not expect to release your narrowband spectrum. Work carefully with your emergency services organizations to ensure that their requirements are met for resilience as well as the basic services. Thank you very much for your attention, and good luck as you grapple with these important challenges for your nation.